AWS Relational Database Service. Hey everyone, Ben Fingal here, and in this nugget, I want to talk a little bit about the different types of data that you can store inside of Amazon, and really that's going to break down to structured versus unstructured data. The structured data being stored inside of Amazon Relational Database Service, or RDS. So we'll talk about specifically what RDS is and how it allows you to spin up instances of your favorite database engine right inside of the cloud, and we'll also spend a few minutes talking about the different disaster recovery and encryption options that you have available to you inside of these services. Unsurprisingly, AWS offers a lot of different data storage options. When it comes to storing your data inside of the cloud, you need to consider all sorts of different things. For instance, the data format. Are you storing little bits of important data or big, large blobs of unstructured data? Your data size, how much space and how much storage do you need? Query and write frequency. How often do you need to look up or search this data, and how often do you need to write to or update this data? And even access speed can come into it for your particular use case, your particular application. So Amazon offers a lot of different ways to approach data storage, and there are a number of different data storage features. They really break down into two distinct groups or headings. The first one, which I call unstructured or blob storage, is going to be EBS and Amazon S3, Simple Storage Service. And what makes those two products great is that you or your application or the user can simply store your data unstructured, your files, your binary data, whatever it is, right up inside of the cloud and only pay for the space that you're using. EBS is actually just a front for a file system connected to an EC2, an Elastic Compute virtual machine. So these are great for large volumes of data that you don't need to search, you don't need to index, you don't need to query. But of course, sometimes you've got data that you do need to do that with. And that's where the AWS Relational Database features come in. So the relational databases, Redshift, RDS, and DynamoDB, represent ways that you can store a more structured version of your data that's going to have different query and searching capabilities associated with it. Now, these applications in the cloud operate as what we call a database as a service, a DBAAS. And to an extent, it's a lot like a platform as a service, a PaaS, in that all of the platform and all the infrastructure is built for you. Now, you may be thinking, if you're a little bit creative, hey, you know what I could do? I could just spin up an EC2 instance, a virtual machine that was backed by an EBS store volume. I could install my own database engine on it and store that database file inside of that volume on EBS, and I would have a database in the cloud. And you would be absolutely correct. This is actually a great way to use things. This is a very useful organization. This gives you a ton of flexibility and power. You can install the database engine of your choice and the version of your choice. You're typically going to have access to the full suite of features that that database engine offers. And if you've got a legacy application that you need to migrate up into the cloud, this might very well be the way that you want to go. But this doesn't take full advantage of the power of the cloud. In this model, you're responsible for the entire configuration of the platform and the database engine, the security that goes along with that, patching and updating the operating system, ensuring that the database engine is configured perfectly correct all the time. On the flip side, if you want to use a database as a service, well, that's going to be potentially cheaper and easier, more flexible and more powerful for you. So Amazon RDS is going to be a way that you can use a platform as a service or a database as a service and forget about all of the management that goes along with an EC2 instance that you might manage yourself. Amazon Relational Database Service, or RDS, represents, like I said, a database as a service based specifically on SQL-style relational databases. These are highly structured relational databases, and we do that to differentiate it from Amazon DynamoDB, which is their no SQL database in the cloud. What's cool about Amazon RDS is that you still have a lot of choice and flexibility and power. Even though Amazon controls the entire platform that the database runs on, you don't have to worry about operating systems or computers, EC2 instances, volumes, any of that. You can still choose, for instance, which Amazon or which SQL engine you want to run on Amazon. So currently they have 6 different engines that you can use, including the really cool Amazon Aurora, which is based on MySQL, but you can also use MySQL, the most popular open source database engine in the world, Oracle DB, SQL Server from Microsoft, Postgres, and MariaDB. And once you do that, spinning it up on a database as a service means that it's simple and fast to deploy. It's incredibly cost effective. Because of all the choice, it's going to be compatible most likely with whatever application you're using. The common administrative tasks are going to be really easy to manage, both through the command line interface or RESTful API, as well as through the GUI interface inside of the web dashboard. It's highly secure. Amazon handles all of the security for you with a few configurable options that we'll talk about in a moment here. and it's really fast to scale. When you need to roll out a large database, that can be a difficult thing to do in your own on-premise system. It can even be a difficult thing to do inside of a fully managed EC2 environment like I described earlier, but on a database as a service, you can scale out really, really quickly and easily. Working with RDS is really simple and easy to do. At the basic level, all you really need to choose is to create an instance of a database inside of Amazon. You do this inside of the web console through the RESTful API or through the command line interface. You choose to create an instance of whatever database type you want to create, and that includes things like read-only replicas, which are a really neat feature. Once you've created that instance, it's an isolated database environment that can actually create one or more user-created databases. So not only do you create the instance, but then you spin up as many databases as you would like inside of that instance. And here's what's great about it. Once you've spun that up, it gets assigned an IP address, and at that point, you use the same tools that you would use that you're familiar with for your on-premise database. Typically, you connect to your databases in your on-premise data center right over TCP/IP. Well, you're going to do the same thing here. Once you tell Amazon to spin up this database, you've got that database ready for you to connect to. You can actually take an existing application, change your connection strings to point to it, and ensure that your security is up to date, of course, and start using that database right away. It's there and ready to go with so minimal amount of effort. There's really nothing you're doing other than creating these instances. Now, of course, managing some of the security and backup around these instances is important as well. And RDS offers a couple of really neat features for ensuring that you back up this data appropriately. First are the automatic backups. These are turned on. These are enabled by default. And automatic backups, just like it says, is an automatic routine backup that's going to run for you. It runs during a daily backup window. It's a 30-minute window that you can configure, so you can decide when the appropriate time for your backup to run is. And the reason you can configure that is because in a basic implementation, you're going to have a few seconds of latency or I/O interruption while that backup is occurring. So you want to make sure that you choose an appropriate time. Now, if that few seconds of I/O interruption is a problem, you can set up a multi-availability zone distributed database. We won't talk about that here, but setting that up ensures that when the backup runs, it runs off of the replica, and consequently, you don't lose any I/O during the backup window. You can also configure that backup to be retained for anywhere from 0, which is disabled, to 35 days. Now, it defaults to a single day of backup, but you can configure those to be retained all the way up to 35 days. And that, combined with the transaction logs for point-in-time recovery, means that you can get back to any point in time for your database within that retention period. So if your retention period is set up for 14 days, 2 weeks, anytime, any point in time during those previous 2 weeks, you can restore to that exact moment that your database was being used. So point-in-time recovery is great. This is incredibly inexpensive. This is all stored inside of your database storage, your provisioned database storage. So if you provision, let's say 10 gigabytes for your database, but you're only using 2 in your actual database itself, well, your backups are going to consume that other 8 gigabytes, and you won't be charged extra until you go over that 10 gigabytes. These backups are also geo-replicated automatically by default for you, so that you know that if there's an outage, you can restore your database in a new region without having to worry about losing any data, because your backups have run right up to date. Now, on top of those automated backups, they also have something called database snapshots. These are manual snapshots that are user-initiated. You and I create these either with a command in the CLI or the RESTful API, or by logging into the web interface and choosing to create a snapshot. And manual snapshots are persisted in your Simple Storage Service account, your S3 account. So they write out to Simple Storage Service, and you pay for the time that they live there in Simple Storage Service. They are not automatically deleted. They are not removed, unlike automatic backups, which after your configuration period are bounced out. These will live in S3 for as long as you want them to, until you go in there and delete them yourself. And another important point is they're only recoverable to the exact point that that snapshot was taken. So you don't have this point-in-time recovery like you do with automatic backups. Rather, if you took it at 3:47 on Tuesday afternoon, well, you're going to be able to restore the database to 3:47 on that Tuesday afternoon using that snapshot. So these two ways combined allow you to create a really good backup and disaster recovery strategy for your database inside of Amazon RDS. Now, storing your database up inside of the cloud also needs to be secure. Obviously, that's going to be one of our most important questions. If you have data that's covered by regulatory laws, well, you can check out the Amazon compliance list that we discussed in an earlier nugget. And you can see that, yes, Amazon almost certainly complies with the regulatory requirements that you are faced with your data. But we've also talked about our shared security model and the fact that it's incumbent not only on Amazon to provide a secure platform for our data to be stored in, but it's incumbent on us to configure that platform in a way that is secure as well. And some of the tools that RDS provides for that include something called, well, RDS encryption. RDS encryption, just like it sounds, encrypts your data at rest. It's built-in, really easy to turn on and off, and it will encrypt all of your at-rest data, including not just your database, but your backups and your snapshots, and any read replicas that you have. So all of your data is encrypted inside of Amazon services without you having to really configure or set up anything. You just turn on the built-in encryption, and away it goes. This uses the really cool AWS Key Management Store, KMS, to store the encryption keys in a separate feature, a separate location, so you can separate the management of that encryption from the actual usage of the database itself. Now, if you happen to be using MS SQL or Oracle DB, they both have something called transparent data encryption, which also encrypts the data at rest using their own features and their own setup. So if you want to use those features that are built into those database engines, well, those are available to you and exposed through the Amazon Relational Database Service. And then lastly, you have the option to use any engine-specific features, security features that you need to use. And that's typically going to boil down to users and roles and groups and permissions that you can set up within the database itself. That allows you to have very fine-grained, granular control over the security and the access of your data that's stored inside of this database. Well, that concludes this nugget on AWS Relational Database Service, or RDS. Just to recap, RDS is a way to store structured, queryable, indexable data inside of the cloud, specifically by creating a database instance of your favorite database engine on a platform that is fully managed for you. We call this a database as a service. You have all sorts of features available to you inside of the cloud, and that includes robust encryption and disaster recovery features. I hope this has been informative for you, and I'd like to thank you for viewing.